Hi everyone, welcome back. In the last video we learned about how this optical flow class is working with default parameters which is given in here, and for this video we are gonna get into the details of these member functions and we are gonna understand according to the parameters we are giving how the results are changing. And in the previous video we went on this example in this highway video, and today to understand more easily we are gonna continue on this billiard video. So with simple video we can understand more easily how the parameters are changing according to the parameters we are giving. Okay, this was the code from the previous video, just extra I added this getting the default values of this class, and otherwise I didn't change much, everything is same. So if you didn't watch the previous video you need to watch that before starting to this one. Okay, maybe we can see the result with default values before starting. Let's run the code and see the result. Okay, so I'm getting the result for each 5 frame, I think. So each 5 frame is gonna give me the result. So I'm just pressing my keyboard and it's continue to a video, and after that it's giving me the results. For example, it's giving the shadow of movement in here, it's giving me the ball movements in here. So actually it's giving me the vectors, and the vectors are giving me the direction of the movement. Maybe we can come to a specific moment, so we can compare all of the parameters according to this moment, so we can understand easily how the parameters are changing the view, changing the results. Okay, we can use this moment, and you see only movement in this ball, and this moment is given by the default values of this class. Okay, we can start with this fineness scale and we can change it in here, and we can see how this is working. Optical flow that set fineness scale, and the default is, you can see in here, is 2. So let's try to give it 1 and how it's gonna change. So actually the terminology says if you give the small results it's gonna give you less sensitive results. What I mean, maybe we can come to that moment and we can compare two results. Okay, this was the default value left side, and the right side is the new value. In here maybe we cannot understand what has changed, but at least you can see in here there are many lines around, and more easily understand there is a movement in here also. But actually in reality we cannot say there is much difference between those two movements, and we cannot, because we didn't change much than the default value. But if we give as 10, maybe we can understand that we can understand how it is changing the behavior. Let's come to that moment again. Okay, now you see nothing in here. Instead of with default it's giving good results. With the value was 2 in here, the fineness scale is 2. In the right side fineness scale is 10, but you see nothing because in here it's really sensitive. So if there is a movement it should be really maybe faster movement or kind of, otherwise it's not gonna recognize, it's not gonna say there is a movement in here. So sensitivity, increasing sensitivity is not really good in here for motion tracking, at least for fineness scale we can say. So I think we have an idea about fineness scale now. I can move this one. We can switch to get gradient descent iterations, and here there is an iteration. So if you increase the iterations, always keep in mind in computer vision, if you increase the iteration, it's gonna be slow, it's gonna make your machine, it's gonna make your process slow. So the default is in here is 16, I think. Let's see again, because we little deleted in here. So the 16 is the default value. Let's copy this one into here, and if the 16 is default, let's give 1. So we are decreasing iterations from 16 to the 1. The expected behavior, the results is not gonna be fine because we are not making much iterations. Let's come to that moment again. Okay, you see it does not give me good results because only one iteration we are set. And if you make 100, which is higher than the default value, let's see result again. Okay, let's come to that moment again, and you see I cannot say really better than the left side, but it's at least same result giving with the default value. So it's not really good, I can say, but it's still better. It's still better than this one, maybe. Yeah. Okay. So iterations is working in this way. If default one is not really good for your case, you can increase accordingly, and you can find your best iteration number. And the patch size, I'm not gonna talk and I'm not gonna try this one, because if we go to the definition in here, for all of the parameters, they are not really trusting their default values, but for this one they are specifically said default 8x8 patches works well enough in most cases, because they wrote this. In my experiences also, this is totally correct. 8x8 is working best for most of the case, and I believe it's gonna work in your cases. So I'm not gonna try this one. For other values we can continue with this get patch stride one. This is very important, I think, maybe one of the most important parameters in this class. Let's try and we can talk about this in the results. And the default value, let's see again if I'm not wrong, yeah, is 4. And if we make 1, let's compare. This was the default values, it is 4, the patch stride, and here we made it 1. Let's come to that moment again. Okay, in here so this parameter is affecting how far the neighbors is gonna be included. What I mean is, for example, for this white ball, this pixel is included to the movement. It's little far to the movement direction, movement object, but it's still little bit considered. You see there is a vector in here, even small, but in this case this is not included, because so I think you can understand now. Decreasing the value is gonna decrease the neighbor including to the movement object. So we give in here 1, so it's not gonna include it for. But oppositely, if we give different values, the default was 4, we gave 1. Let's make 8 little, which is bigger than the default one, and compare again. Okay, let's come to that moment again. Yeah, in here the expected behavior is increasing the neighbor include, but maybe for specifically, okay, maybe for this example at least we don't see the result, but I can say increasing the number is also increase the neighbor include for this one. Maybe we can, if we come to this moment for the default values, for example, you see in here it's even including this one. So I mean this, if you increase the number of patch stride, it's gonna include more neighbors. Okay, we can skip this one also. These two also important. If you, but let me tell this one, if you always set, which is default is true, if you always set this parameter true, you are not gonna get into trouble. Only you are gonna lose the speed of your machine, nothing else. But if you know this parameter is used to smooth the background, but if your background is already smooth and it's not really noisy background, you don't need to set this parameter into the true, so you can make it false and you are gonna get efficient process. But for example, in our case, this background is already smooth, it's not really noisy, we can set this parameter into the true. Let's set it, I mean false. Let's set this into the false and see the result. I believe it's not gonna give me really trouble results. Yeah, you see almost the same behavior we get because my background is smooth. But if it's a noisy background, maybe in that case you need, if you set it to the false, you are gonna get bad results. But you need to keep in mind, if your background is already smooth, you don't need to make this you don't need to use this in the default true values. You can make this false and you can get efficient program. Okay. This is also this is defaultly also true, but you can make this also set to the false in the case of if you are having really faster objects in the scan. So this is important. If you have really faster objects in the video, you need to keep this as default, which is true. But if you are using not really faster objects in your video, then you can also make this into the false. Then you are gonna get an efficient program. So I'm not trying this also. Let's try maybe, but again, since my object is not really faster, keeping this into the 0 is not gonna change the result much. Let's see and come to that moment. Yeah, almost the same, so it's not changing much. It's giving me the correct direction because my objects are not really faster, so even true, even false, this parameter is not affecting much. These three I don't want to talk much because these are really details. I don't really know about this one, but if let's try maybe just what I have an idea about this one. If you keep this into the for example, the default was I think 20 or yeah 20, the default value. If you keep this into the 1, let's see the result. You are gonna get yes the longer vectors, which is longer result. But if you keep it the higher values, which is maybe 1000, you are gonna get small lines. That's what I know about this parameter. Maybe we can come to that array again. You see it's not really longer comparing to the other one. Also the gamma, if I'm not wrong, the opposite. If you keep longer values, it's gonna give you longer vector. Yeah, for example, you see this is really longer lines, is giving you longer vectors. But if you keep it 1, it's gonna give you small. If I'm not wrong, yes, it's giving small lines comparing to the 1000. I can say, yeah. But keeping this default, if you are not really familiar also, is better. This is also iteration kind of. Let's see the result. The default is 5. If you keep 1, the expectation is getting bad result. Maybe not really bad, but there is some noise maybe around. Yeah, I think also not really bad, but if we get 1000, it's gonna give really good result, I will. But you cannot maybe understand, but I feel it's really slow. Even I'm pressing my keyboard. Okay, this is good results, I think, because you see only the object side giving me some even small vectors is giving me in the correct place totally, so there is no noise around pixels. Let's see again. Oh, I missed again. Okay, I think this is really good results because these pixels are empty, only giving in the correct object position is giving me the vector. So this is, I think, good results. Of course, it should be also good. It's really slow and making many iterations to give you good results. Yeah. I think I'm done for this video. We already talked about all the parameters. I hope it's helpful. Thanks for watching. See you in the next videos.